Yeah, welcome. Thanks for joining the session. As you see in the title, Beyond the Inconsistencies, or what we call it, Paving the Road, which basically means what we're going to talk about in the next 15 to 20 minutes is how we at Capgemini with our clients work on how to really match and meet all the needs for more requirements, faster requirements, quality, and basically consistency to go beyond the inconsistencies in automotive vehicle software development.
Yeah, I'm Fabian, managing delivery architect at Capgemini and working here since a couple of years. And now I'm a cloud architect for systems.
Yeah, and I'm Wolfram. I'm Enterprise Architecture Director for Capgemini, working with cloud architectures and in-vehicle infotainment.
And my name is Stefan Krause. I'm head of software-defined vehicle at Capgemini. And this is what we're going to talk about today. So we all know that, right? As a developer in web development or having the speed of native cloud development, it really takes only a day or two to get from an idea down to something deployed in the actual environment. And automotive development has slightly longer development times. So this is what we're going to talk about. So imagine, right? Imagine how to go from an idea you have in the morning, an idea you want to have in a vehicle and test it out in the evening and have it engineered by them, and really be able not only to deploy it to a test system, but deploy it to a system where if it's working there, I can take it to my vehicle, I can take it to the fleet, and I even can take it a step further then and get all the safety certifications, all of that. And that's the general idea about that. Really speed up the process, and it's all about efficiency, and it's doing the efficiency, doing the speed by still keeping the quality you need. Because quality is important in the certain steps of vehicle development because it's regulated, right? It's not like just web development. It's an environment where you really have to go through first safety certification, security, and the more connected our world is, the more connected our vehicles are, the more important it becomes that we really know what's going on and really work with all the requirements and build a consistent software. And that's the other challenge we have, really deal with all the complexity that arises. Having said that, all this transformation, and we're going to take it actually from something like that. We all know those ideation sessions, right? You get into a room, have a very creative environment, just sitting and standing in front of a whiteboard and put down your ideas, scribble it down. And then someone at the end of the day collects the flip charts, makes photos, and it just fades away. What we're going to do is you take a photo of that and put it into a process to really get what we say, imagine it going from a scribble on a whiteboard to a list of requirements.
Yeah, and for this we have developed an accelerator. It's called Amplifier. You can see it at our booth. And what it's doing, it's using large language models which are deployed on AWS Bedrock. And those models are using prompts we have engineered for this purpose, which are extracting information from the picture, then taking this information to create a consistent set of requirements. We have built features to test the requirements for ambiguity, and we can also create user stories from this. So user stories which are ready for refinement, ready to hand them over to the development team. And this way, we accelerate a process which takes days, weeks, to hours, maybe. Yeah, so we do it every morning. So it takes, let's say, for our demo set of requirements, we have a pet mode application running on Android Automotive. It takes about 15 minutes to get through this whole process with over 30 requirements. Having done this, the challenge in automotive is that integration takes a very long time and happens very late in the process. So if you have an idea for a new functionality in infotainment, until you can really test it against the devices, the ECUs in the vehicle, it takes months, sometimes even years. And then you discover very late that you most probably have misunderstandings and that things need to be fixed, and remediations become expensive, become timely, and the quality is suboptimal. And as an architect, what I would like to do is to develop in-car software in a similar manner as we do it, for instance, on the cloud, which means that we have short iterations, that we can build prototypes, quickly spin up environments, use them to test out things, that we can work in maybe 2-week sprints, that we can discuss with product owners, gather feedback, and develop our architecture from this. So what we don't want to have is that we write thick architecture documents and then hope that they will be implemented in the proper way. And for this, what are we doing? We are using virtualization on AWS Cloud.
Exactly. And as a developer, what I don't want to do is to take my stuff, putting it on a USB stick, going to a rack, flashing it, and really waiting for this rack, waiting for these resources. They are raw, they take time, and I will not be finished in the evening if I do this process in the end. So now imagine I have a complete environment available for my own development with all the components that I need for my feature. For example, a climate control, battery level. That would be nice. So I can really start developing with that, integrating in my local environment, and really start finding out where are the issues, sitting together with my team, and solving them on this real example. I'm sitting there, have my environment, have the virtualized ECUs. They are provided by the ETAs, so they are really going there, taking real software from ECUs. We can really see how they behave, and I can find out what is not working and how it feels like to work with it. That is really a great benefit. You can see this in our demo, for example, if you visit us. But if you just imagine how it could be to develop such a thing, that's already nice. So another point is, if you have this running with the virtualized infotainment, with all the components running, you can go to your product owner and say, hey, this is how my complete app behaves at the moment in a real car situation. And then you can also identify issues with that and can continue to create a product that really benefits the users in the end. Another point that we have for the developer is that we are creating test cases so that we are doing a shift left. We are integrating the tests now into the development lifecycle and into the development phase very early. So if you have the complete environment available, you can create automated tests. This is again combined with the amplifier, the accelerator that was already mentioned. So we create a consistent set of tests from the requirements that we have created in the morning, so from our whiteboard. And we take those requirements, create tests and automated tests so that we have a structured testing available and also a consistent way of testing.
And what we've heard so far is, we've gone all the way now from our scribble on the whiteboards, you've seen that, generating the requirements. And this is the basis for everything. This is the basis for the architecture we talk about, and meeting and matching with all like vehicle car lines, variants, different model years. We talked about the developers at your fingertips having that available and being able, based on the same consistent set of requirements, to work with their Jira tickets and their test cases and the test automation, because that's the basis. And there's one thing missing at the end of the day, because now we talked about the developer doing that, but honestly speaking, as we all know, vehicles are not single instances running on a street. It's multiple of them. So let's talk testing, let's talk scalability, let's talk about the fact how you then deal with the idea of, well, there's this one set of my virtual vehicle with the 3, 4, 8 ECUs I want to test. I integrate and test it against, and now I need to scale that. Now I want to test that with a fleet of 1,000 vehicles, right? Because I've done a change, one of my security area protocols, and I need to test my backend infrastructure, my digital twins with that. And you don't want to find out as soon as you publish that change to 10,000 vehicles on the street and your backend crashes. So now you take that same virtual infrastructure, you need the same test cases, put it to AWS Cloud and just scale it up with a script. And that's the power of the cloud, right? And this is really what we're trying to deliver. We're delivering the speed of native cloud development and the power of cloud actually to vehicle development. And just having said that, and Wolfram mentioned it, Fabian mentioned it, this is not slideware, real. This is real, and this is what we've been doing. And just to give you a short glimpse how this looks like, so on top you see the development process, which is typical, and you see that we have the V model there, which is still relevant. There are parts of the V model we still need because it's regulated, it's safety, it's automotive development. But we moved that to a more iterative process. And we can do that because of all the generation steps, and honestly speaking, because of the understanding that GenAI text understanding gives us, we can make sure that even a totally different phrased environment and requirement really gives us the notion of, okay, but it's the same thing. It's similar, it's different. So we really can go into an iterative way of architecture and development, even when we start with a classical V model. We left shift, what Fabian said, the development process. You don't have to wait for, you all probably know that if you're working with hardware, A, B, C models, so you get some hardware available to test, you can do it from day one. So the development starts way earlier and gives you a lot more capabilities to test things. Will there be hardware tests in Hilrex? For sure. Because there's a number of things you only can do in hardware that need to be done, like timing tests, safety certifications. But you can take a lot of this burden away in the process because developers working day by day with it. There's not this like, I don't know how to do it because I've never done it before. The guy that's been doing that has vacation today. We're just reusing it. And you push that, and that's the DevOps idea at the end of the day, transported into automotive development, being able for the developers and everybody else to really work together because we're delivering this end-to-end chain. And on the bottom, you see that this is where we have our amplifier system using the Bedrock models, using GenAI, using pre-trained and, for example, LoRa modify AI models using RAG databases. And on the right-hand side, you see all a part of the infrastructure running on AWS. We're using Engineering Workbench, which is a great asset from AWS to really make those things available for the developers at their fingertips. And ATA's Virtual ECU Builder, which gives us the power of really being able to take the ECUs to the virtual world and integrate it into code pipelines. All of that's then integrated, and you see that here. And if you want to have some details, come to our booth, we explain it to you. In an automation as you get it from a DevOps, right? So this is all scripts, this is all automated. It's based on state-of-the-art technologies. And then we have basically our infrastructure here that is capable of doing all the necessary things you're going to need to virtualize parts of a car for the need of the developers. And that's the important point, right? What we tackle with that is it's really all about consistency, it's about efficiency, and it's about dealing with the complexity of model years, car variants, and all the things that are about to come. Because let's face it, with all the ADAS stuff, with all the new features, with all the infotainment we've seen, what we need to be able to do, we need to enable our developers to deal with that in the most efficient way. Having said that, we started with an imagine and we close with an imagine. Imagine you can experience that today. And with that, we're going to close and thank you very much.